Hello, everybody. Welcome back to the Big Bad Bench. Today, we have my culmination of awesomeness as a YouTuber, where we'll be going through this little board I designed to put SCSI internally to a Macintosh Plus. It's probably going to be a nightmare, and so you'll probably wind up falling asleep during a lot of it because this is a process. I should say in advance, just don't do this. It's kind of a stupid mod. How's that for getting people hooked to want to watch this video? But anyway, so let's get started with this. Oh yeah, I should say hi to everyone in the chat. How's it going? Oh my God, there's so many people. Tech Ambrosia, Vic the Vicar, Dave's Vintage Apple Tech, K-Mac Vintage, The Pan Manager, Chris Angelis, Helen Gracia, Garth Beagle, Mac 84, Action Retro. Wow, everyone is here. So yeah, hopefully I'll be done by 2:15 so that Trina will be good to go. So let's get right into this. So a while ago, I did a stream about where I put SCSI internally to a Mac Plus, and basically the mod was that how easy it is to see here. We just soldered the SCSI cable right to the SCSI chip, and it worked great. It was a nice, little mod, and actually, this is probably easier than what we're gonna do today. So, this is something I wanted a more elegant solution, right? We wanted this to be fancy because we're Mac people. Mac people are fancy, and so let me give you a preview of what we're gonna do today. So this is my little PCB I designed. The PCB details are all up on a GitHub that I posted a link to in today's video in the description. You can go to the GitHub, and so this is a little board. Here's our SCSI chip. Basically, we solder a bunch of connectors onto it. Shut up and take my money. I don't know if you're gonna want that after this. So we put in some headers here. We have this little board that's detachable. Everything is out of focus, and so it's kind of interesting. It takes a lot of work, but it works, and so it's kind of neat. So if you have your BlueSCSI, I don't have one right in frame right here. Here's one in a bag. This works really cool. Well, it works really well for BlueSCSI. So let's get started and sort of review how this whole process goes because it's going to take a while. Set this aside. All right. So what we're starting off with here, I gotta lift this up. So you can see we have a Mac Plus that I restored last year. It's basically a bone stock Mac Plus. I'm going to just shut this down. Okay. So the first thing we want to do, and this is not going to be easy to see with the camera, but you want to check your voltages. Oh, Trina's Technobabble. I mentioned you, but yes. Hi, Trina. I'm sorry I didn't say hi specifically. The first thing you want to do is just double check to make sure your voltages are good before. So there's our battery. That one should be a negative 12. So that's positive 12. Yeah. The next one should be a ground. The next one should be negative 12. Then we have a ground. And we really want to make sure our 5 volt looks good, okay? And so make sure your 5 volt is good, or else you're going to have issues getting this thing to work. And Eric Helgeson is here. Thanks for joining, Eric. So you can see our little BlueSCSI hanging off the back. So this board, the only thing I have done to it so far is that I added the diode so that you can have externally powered BlueSCSI type devices. So this thing is oh geez. This thing is good to go, as opposed to my mouse, which was on the floor. Alrighty, so let's pull out our logic board. And Set that aside. Okay, get rid of our BlueSCSI here. And now it's time to get to work. Okay, so the first thing we have to do for this mod is to unsolder our SCSI chip. So let's hop into the microscope for that. And can I get my microscope? Oh, that's too far. Why is my microscope not wanting to focus? Because we're upside down. Got a lot of glare today, I'm sorry. Alright, so the solder on this one looks pretty good. So we're probably gonna be okay with this. Sometimes it helps if your board's kind of corroded to start with a fresh coat of a fresh application of solder, just to make it a little bit easier for everything to flow. And Gut Bombs here, how's it going? And sorry if I missed anything in the chat. That was a lot to catch up on. What the heck are y'all doing here? This is so stupid. Why would you want to watch this mess? So if you have a desoldering station, this would probably go a lot easier. I have my trusty solder pult. And it works okay. The problem with doing it with this is there are two leads on this thing. One is on the 5-volt plane and the other one's on the ground. And those absorb a lot of heat, and so it's really hard to do with the solder pult. Nice relaxing stream before your stream, yes. Your stream, I'm sure, will be something else. Did I say hi to Tech Ambrosia? I should have. Hi, Tech Ambrosia, if I have it. Alright, so I think that was our 5-volt. You can see how the solder didn't come all the way up out of that. Man, this thing just doesn't want to focus today. I really am sorry for this. This board's very shiny. My other Plus boards are not this shiny. Sometimes the solder pult gets full. I did say hi. Okay. Tech Ambrosia will be streaming today, I think, at 4 o'clock Mountain Time, 6 o'clock Eastern Time, I think, if I remember correctly. Trina and Tech Ambrosia, feel free to add your links to the chat if you would like. This is the problem with the solder pult. Sometimes we get little chunks of solder that get built up in there. Alright, so that's about halfway done. We're speeding right along here. So this board isn't anything fancy. All it is basically just a little connector that lets you put a real SCSI cable onto the board. There's not any real circuitry. I will also say that if you take a look at my KiCad or Gerber files, whatever you look at, you can tell that I have no idea what I'm doing when it comes to PCB design. I do want to thank Eric Helgeson for he looked over it, one of my original designs, gave me a lot of tips, so that was a huge help, because basically I had no idea what I was doing, and I guess technically I still don't really know what I'm doing, but he helped me get this thing to the finish line, and that's important. The other thing is, some of these, I know on my other Mac Plus that I've done, the pins on the SCSI chip were all folded over the really annoying way. And so the first thing you have to do is go through and like unbend all of those pins, like heat up your solder, get the pins unbent, and then here, and then you can come through and unsuck, or then come suck your solder out of there. Okay. And Tech Knight here, how's it going? Is it possible to upgrade the SCSI chip, or does the Plus ROM expect a specific chip? That's a really good question. I have no idea. If anyone in the chat happens to know, please feel free to answer. I do not know anything about ROMs. Gutbomb, no, I don't have a vacuum desoldering pump. This is my system right now. Currently saving up for a new soldering iron. I'm currently on my backup weller. My old weller died several months ago, so I want to get a new soldering station. I also needed a better microphone, so the desoldering station is down the list for me. But I've been using this solder pult for a lot of years, so I'm relatively comfortable with it. Okay, so we can see we have, oh no, you can't see anything. One pin there that's not totally empty, and that pin there. So what we're going to do now is I'm going to go away from the microscope, go back to this. Let's zoom in a little bit. So what we're going to do at this point is use the hot air station to remove the SCSI chip the rest of the way. So there's very little solder, and I can actually feel the chip wiggling a little bit right now. And I'm not gonna pull on it. I just have my tweezers in here, right this, and I'm gonna come in with the hot air and just hit this until the chip basically falls out. I'm not really applying much of any pressure to the SCSI chip. I'm just sort of letting the heat do its work. I'm currently at 350 degrees. chip is moving. And again, I'm not really applying force. I'm just sort of letting it work its way out. There's a little bit. It's caught on something. Oh, geez. That's probably not good. Yep. That was not ideal. Okay. So our SCSI chip is off. So what we want to do now is make sure that all of the solder is out of our holes. Oh, I shut that off way too soon. Don't ever do that to your hot air station. Okay, we're going to come in with some solder wick and clear out the holes. Go back to the microscope. You can see we have a couple holes that still have some solder in there. See how this solder wick does. I just bought some new stuff. I had ultra mega cheap solder wick. I bought some nicer stuff off of what's his name, Northridge Fix. I bought some stuff from him, so I wanted to try his solder wick, see how it goes. Sometimes it helps to have a little bit, since this is like down inside the hole here. I'm just gonna make it so it's a little easier to get thermal transfer down to there. Come on, you thing. Just doesn't want to go. There we go. Okay, these all look good. That one. Okay, so we have some solder up near the top. Let's see how good this stuff does. Hey, that worked nice. Way better than my cheap wick. Whenever you're using wick, just be really careful. Never remove your tip and then pull the wick away. Always make sure to move the wick with your tip attached to it. Yeah, the cheap flux I bought only works if I add, or the cheap wick that I bought only works if I add expensive flux to it. Okay, so all of our holes are empty now. So let's go back to here. And this. Okay. Alright, so here's our board. We're going to have to start assembling that. The other thing we need, so let's review all the parts we're going to need. So basically what winds up happening is we use 2 rows of pins for our SCSI connector. The reason we do this is it actually winds up saving us a little bit of space. The next thing we have is pins that go, let's see, where does this go? Pins that go down to connect the SCSI chip down to the board. And so that goes like this. All right. And then we resolder our SCSI chip onto this board like this. We have a jumper for termination power. We can install a diode if we want. I'm going to just install a jumper today. And then, so this makes a little board that we can plug down into the logic board. So what we need to do is put these header sockets down in the logic board first. So these, yeah, so this is just my little board that's adding internal SCSI to the plus. Nothing fancy. There's no like electronics or anything on this board. It's just a dumb board. Okay. So there's that. Since all of our holes were empty, the sockets went in real nice and easily. The one thing I'm going to say here is when we put these sockets in, when I go to solder them, so I don't know if I can really get a good angle. I'm not going to have the sockets touch the bottom of the board. I'm going to leave them kind of sitting up a little bit because, one, it gives us a little bit of flexibility for once we put everything together. But two, we need as much space unless we chop this bar down. We need as much space as possible for the connections to go between the two things. So you can see how I have that's totally pushed in. When we solder it, we're gonna leave it like this just to gain, an extra millimeter or two, basically. Yeah, it would be neat to hack the ROM to support the super drive on these. Alright, so I'm going to just come in, add a little bit of solder on that one. And then I'm going to just pull that out until I get it at the right level I want. Okay, I'm going to come in, do the same thing on the other side. Okay, so let's see if you can see this. Ugh. So you can see I have this one. Basically, the ends of those pins are all flush with the bottom of the board. This is what it looks like if you push the pins all the way down. We're going to do the same thing to this side. Bring it back up a little bit. Justin D. Morgan, how's it going? Can you use both the SCSI connectors at the same time? That's a good question. I haven't tried that yet. I don't think I've tried it yet. I don't remember. I might have done it. I forget. Most likely. Just going to come in. Just want to make sure that this thing is out there. Make sure that's out there. Okay, now it's going to be rapid fire soldering time. So let's go back to the microscope. Crazy furnace guy. Even my old weller is not quite happy with me right now. Oh, connect the solder. Yeah, that's a good idea. shaky today. Don't do anything cool while you're in the shower. Okay. I can promise you that nothing cool is going to happen today on this stream. Come on. Sorry. One of the reasons I don't like my microscope is that in order to use the camera, I turn to monoscope view or monocular view, and I have no depth of field in here, so I don't know what's where. I can see smaller, but I can't see depth. By the way, one of my SCs has started to subtly tick on occasion. So that is actually something we might actually see with this plus that we're installing this into. It ticks, and it only does it when I have a floppy drive installed, and so I don't know what that tick is. I was wondering if it might be maybe the floppy drive needs to be recapped or something. I was never a big proponent of recapping floppy drives, but I actually recapped one recently, and it brought it to life. So maybe there's something to that. Oh, Vic, do you mean that? Do you mean that it ticks and won't turn on, or do you just hear like a little ticking coming out of the computer? Yeah, solder joints look like crap. Not nice and shiny. I think it's time for a new tip. It's hard to find tips for 30-year-old soldering irons because the tips are all 30 years old and kind of corroded. I feel like I'm doing this logic board an injustice by having these solder joints look so ugly. Okay, so we have our socket installed now. So let's go back to here. Okay, so there's our socket-ish thing on the SCSI port where that chip goes. So the next thing is when we put this together, so I'm going to put these headers down in here. We need to think about an order of operations when we put this together. So our SCSI chip goes this way. Let's just make sure this one pin I got tangled doesn't get all bent up. I'm gonna pull. Got a little bit of solder on these. Just making sure all of our pins are nice and straight. Okay, so don't always make sure to put your chip on the right way. I'm living in fear of that right now since I destroyed an EEPROM recently. So if we were to solder this chip on, we wouldn't be able to solder the other connectors in there. So yeah, the first thing we got to do is solder our headers in. Okay, so let's do that now. Back to the microscope. Yeah, I think it might be from the floppy drive itself. The one thing I hadn't thought of trying is it's a little better, I guess. Seeing if it's that particular floppy drive that causes that ticking. I'm just going to come in, hit all these. I should also mention, so, between these two connections, between this one and all of them, they're just straight across. And so theoretically you could do this either way. There are two different types of Mac Plus chassis. And I'll show you the difference in them later on. The chassis that I'm going to install this one in, it's better in this orientation. With the SCSI chip pushed forward as far forward as possible. And I'll show you why in a second. Well, not quite a second, but when we get to it, I'll show you. I'm hating everything about the microscope today. Oh, we're only at 12:37. I thought this would have taken an hour to get to this point. So we're like 20 minutes ahead of schedule here. Let's clean that. Oh yeah, I forgot to also mention for Will, KMac Vintage, that thing that I did earlier where I checked the voltages using the analog board to logic board connector. Will has a way to do that easier where he's got a little PCB design that'll show you the voltages if you just hook it up to the floppy connector. So check out KMac Vintage for more information. This is the part where I'd like to have Steve on stream with me so he can sing to keep everyone occupied while I do my soldering. I don't have that singing voice. Could make calming mooing noises. I think I'd be good at that. Alright, so now let's go back to here. Okay, so we got our little PCB soldered up there, nice and tight. Gonna give this a rinse real quick because once we get the SCSI chip on, we won't be able to really wash. I guess we could stick the whole thing in the ultrasonic bath, but may as well clean it now. And I'm almost out of isopropanol. Let's overdo it. Okie dokie. So that's all nice and clean. Okay, now we're going to come in, put our SCSI chip on. Okay. And we barely have enough space to do all the soldering we need to do. Let's get rid of some of this isopropanol. And back to the microscope. Yeah, my original design had a socket there, but it's too tall, unfortunately. It's very sad. I can show you my fail boards in a minute. Yeah, also the SEs that have Apple branded power supplies, I don't know if that's the Hitachi ones that you're talking about. Those power supplies need to be recapped. I found that Sony's are totally fine. But sometimes you do need to tweak the voltages on the Sony's. But it sounds like Vic's SE's voltage is good. Did I solder that on the right way? Okay. My brain is like I'm nuts that I might have soldered that on the wrong way. Putting that EEPROM in the wrong way like totally it killed my confidence. I feel like I can't do anything anymore. Well, there you go. If recapping feels like a meme, maybe you just want to get into putting internal SCSI ports and Mac Pluses. Change up your change up what you're doing. Come on. Gosh. All right, this is kind of annoying. Let's see if we can make this a little bit better. Let's. Oh, jeez. Sorry. Wow. Y'all went for a ride. Your Sony. Guess what? Let me guess. It's a bad transistor. Bad MOSFET, I mean. Of course. Caps. Okie dokie. So that's the SCSI chip. We're probably 2/3 of the way through here. All right, so there's our thing. Um, Probably don't need to add this jumper now, but we're not going to add. Well, we'll still do it as a jumper. Yeah, okay. We'll do this one outside of there. Alrighty, so that's that. So I have a spot here for a diode, if you want to put in a diode, but I think we're fine with just using a jumper for today. We shouldn't really have to worry about it as long as you're not trying to use a regular drive with this. A jumper should be fine in this position. Okay. Yeah, so that was the reason that I'm saying to use a jumper today. So for one of these that I have that's working fine, with the diode installed, the voltage dropped to about 4.1 volts or 4.17 volts, which is a bit too low for what you'd like to see for the BlueSCSI. Okay, so we got this, our SCSI chips in, our orientation's correct, we got our jumper installed. So this is a really stupid design thing that I have here, but this one, so what we're gonna do is we want to connect this thing underneath. Right? There's no room for a lot of stuff in here, and I was originally worried about like whether you could do stuff from the top, and also if you have the pins sticking up, well, one, it's wired up wrong, so don't ever do it with the pins sticking up. You got to have the pins sticking down. I originally designed it with the pins sticking up, but then you can't like slide the board in the back with the pins sticking up, so we need the pins to stick down. And if we were to put like a regular, like if we had a regular like SCSI header, right? If this is, I forget which one's pin one, but whatever. You know, if we put this on here, it's too thick and there's not enough space. So like this plastic that, you know, is underneath the header down there, it makes it too tall. So we need to keep that as thin as possible. So that's why. Yes, and I did try the right angle header, and it basically bumps into here, and so that didn't work. So my workaround is, so we take our 50 pin SCSI cable, we use our little headers, and then this is probably the most exciting bit of this whole ordeal. We get our vise. Just to make sure that there's enough pin that goes down into the SCSI connector, or the SCSI cable, we go like this. Yeah, this is like right out of an Action Retro kind of rig. Smashy smashy. Okay, and so that's what we do for this one. One of these didn't go in all the way, so we're just gonna push that in with our finger. Okay, so that basically sets the tone, right? So you could see, let's get rid of our vise, we're done with that. If we compare this to a regular header, you'll be able to see like how much space we've gained. So you can see it, basically we just smashed it down a little bit further, and that just ensures that we're having good connection to the SCSI cable. So then we can come in, and now we got to solder all these things together. I need to buy a vise now. Oh, that's funny. Oh yeah, here's one. So this one was one of my fail attempts. This one did have a full 50 pin like right angle connector, and this one just goes too far. And so then what I did was I hacked all these off, and this kind of works now, but this is way a hackier job than doing this mess with the vise. So I recommend the vise method. Oh, I lost my header. Okay, here we go. Let's put that back in there. Put all of our headers away. And let's go back to the soldering iron. Or the microscope. Of course we're going back to the soldering iron. Alright. Let's see how we can get this. We're giving you all a headache with this out of focus microscopy work. What do we got here? Oh, let's use this right angle 50 pin header. That's nice. Okay. That's kind of in focus. Might be our best focus of the day. Okay, so I'm gonna tack one in the middle here. Tack one down here. And then I'm just going to come in, reflow it, make sure it's all the way pressed up against the board. Okay. Do the other one while we're here. Trust me, folks, I am a professional. Oh my God. Come on, you thing. Okay, that side's in. Alright, so that's all aligned, right? And it's nice up against the board. So now we just got to come in and solder all these beasts together. And then we're like basically there. Almost. Oh, right. Yeah, there's other stuff we got to do. Because, it can't be that easy. Oh my God. I really need like a soldering clamp thingy. Problem with these pin headers too is you do kind of have to work fast. They do like to melt, and that causes alignment problems with your pins. surprisingly. So, see that one? I moved. It moved. Getting close. Getting close here, people. Okay. Only 25 more pins to solder on here. How many pins have we soldered today? I haven't even thought about that. I don't think I need any more nicknames. Although I would, if I had started using John the Vice 25 years ago, that would have been fun. 20 years ago. 20. When did Big Bad Biologist start? I think it was 2000, 2001. We're in the home stretch, people. Who's still with me here? I'm barely with me here. Oh, thank you for hanging out the whole time, Alan. All right. Whew. And Chris is still here too. Tech Ambrosia's still here. All right, let's go back to this. All right, so you might think, hey, we have our little PCB made, and we got our SCSI chip on there, we got our sockets installed, and we're done. Well, no. We were so close. Garth is still here too, and so is Trina. Thank you all for... And Gut Bomb. Alright, so what you're going to notice here... yeah. This little capacitor right there. So there's some clearance issues. And then we have the same thing on the other side. So basically we gotta unsolder. Oh, God, you can't see anything here. Okay, see that? This cap right here. This cap we can just pop it out a little bit and slide it that way, and it'll be fine. This one we could do a couple things. We could actually just put a new cap in, and maybe that's what I'll do. Do I have a 33 microfarad? I might not have a 33 microfarad. No, I don't. So I can't replace that one. What I did with my other one is I just took it off and put it on the back, and that worked fine. Okay, so what we're going to do is this one. Oh, this one is one of those angry bent over kind that are annoying as heck. So we're going to hit that with some fresh solder. And then we're going to bend that pin up. Gonna get the other side too. I'm sorry, Garth. Has today not been enough pins for you to solder? We could install it on another Plus. Yeah, that one's gonna need some more solder. I think that one's the ground plane. These caps suck up heat, or these solder. These solder pads suck up heat. Okay, that one's out. Out. You don't stay there. That would short something out. Alright. Well, let's pop. Clean off some of that solder. Trina, do some people not solder everything that needs to be soldered? So I think that'll get us enough. Alright, so you can see there, we basically just pulled it out, shifted it over a little bit, and I think that'll give us enough clearance for what we need for that side. Yep. Okay, so you can see we have more clearance there. So that one's good. So this cap we just shifted over. So we just unsoldered it, pulled it out as far as possible, and then that should be good to go. Oh yeah, the other thing I want to do before I forget is I don't think this is totally necessary, but like I worry about this sharp metal bar scraping somewhere around here. I should have some, yeah, electrical tape. I worry about scraping these traces, and so I just put a little piece of tape on there, to some electrical tape, just to make sure that it's a little bit spaced away and a little protection. Hey, Eric's Edge, how's it going? Okay, so we're gonna come in, lay some of that down in that slot. And it looks all professional. See, now we're protected all the way across. All right, now we got to get this cap off. Now we're going to move it to the back. Solder. And I forgot where it is. Oh no, it's this one. There. Right there, I think. Let's double check. Yep. Okay, come in. Okie dokie. Didn't bend that one far enough up. There we go. Beautiful. All right. Get rid of our extra solder here. And let's get the solder out of those holes. Come back to the other side. Oh, solder pulled. All right. So what side's negative? Plus is over there. Minus is over there. Okay, so that's that. Soldered that on. Soldered that on. Dave, no, I'm not gonna sell this. I'm just releasing the PCB files. I don't know if any of our crew that sells stuff is interested in selling them, they can get a kit together, and feel free to sell it on their website, like Joe or whatever. How long have we been going? An hour, 15 minutes. All right, we're looking good here. I'm feeling pretty good about this. Okay, so the other thing we need to think about is that, you know, your floppy or your, well, floppy, whatever kind of cables you're dealing with, whether it's IDE, SCSI, whatever, some of them are just like this, and some of them have the strain relief or like flip around 180 thing. We have to use this style that don't have that. Sorry. Okay. The other thing is, when we're looking at this, pin 1 is down here. You can see the little, it looks different. Come on, camera. Why is nothing in focus today? So there, you can see pin 1's down here. So just make sure that your cable is there, and you can pop this in. So the other thing that might get in the way is this. I don't know if it's a MOSFET or whatever. Voltage regulator. Nope. Actually, that's great. Okay. So no, that totally clears. So if you put the SCSI chip in these holes and put the pins in the other holes, then that shifts all of this slightly back, and the SCSI cable interferes with the SCSI cable connector interferes with that MOSFET or voltage regulator, whatever it is. But when it's forward like this, there's enough clearance that you don't have to do anything. If there is clearance issues, so like what I did on this one, I just cleared a little bit of this out of the way, and that's enough to provide the clearance that you need to get that on there. So this one, you can see sort of the difference in how I assembled these. So you can see on this one, I mounted the SCSI chip towards the back position, and on this one, the SCSI chip is in the front position. And so let me show you why that is necessary in certain situations. The other thing to see here, our floppy cable is still accessible, and everything should fit in nicely. Okay, so let me show you the difference in the chassis. So see this chassis? Yeah. So the way this thing is made, there's like a little 90 degree that goes around all of the holes. And for this type of chassis, you need to mount the SCSI chip in the back position. Otherwise, the SCSI chip kind of bangs. Let's see if we can make you see this clear. Ugh. Okay. The SCSI chip like runs into that ridge. And I also find it's better, see how I bent that one up? It's better to do that, gives it just a little bit of clearance. And so that's what you have to do in order to make this one work if your chassis is like this. The one that we're going into today, where did I just put my plus? Okay. this version of the Plus. I like this one a lot better, for this mod at least. There's no ridge on these back cutouts, right? They're there on the front of the cutouts, but for some reason, it's like they knew I was going to design this little board. And so this is like totally flat. There's nothing that you have to worry about there. So theoretically, this should all go together. Let's zoom out a little bit. We should be good to go. Oh man, I'm shaky here. Oh, the other thing, no, there is one more thing I need to do. So what I'm gonna do is I need to take off this little thing and then bend our pins over. Okay, and then hopefully I have a good... So one of the issues I had with mine was I spent months troubleshooting why this wasn't working. It turns out that the jumper I was using was mangled internally, and I didn't notice it, and so it was not making a solid connection, and it was causing all sorts of issues. I also found out that the analog board connectors, the solder joints were cracked, so that also was fighting against me. All right, I think we are ready to go here. Who else is excited and nervous as heck? All right, so you can see you can just put your SCSI cable through there, and then hopefully everything should just slide right in there. You might need to like give it just a little bend when you're coming out here, and then everything should fit real nicely in there. Okay. So there you go. You can see it's all in there. Yeah, let's see if you can see that any better. Oh gosh, this is really hard to show off. Okay, so everything fits real nice. Yeah, drum roll. Let's see if we get sparks. All right, so where's my BlueSCSI that was in there? All right, so the first thing we're gonna do, we're going to start with the BlueSCSI that we used originally to boot this up, just to make sure that I didn't screw anything up with the SCSI. So I know that'll be boring, but if we don't make the fire, then that's a good indication that we're on our way. All right, power's on. All right, let's get the SCSI cable out of the way, because if there is fire, you all want to see this. I know, Trina, you're such a great supporter of... Okay, 3, 2, 1. Uh-oh, flub. We got flub. That means we got a short somewhere. Uh-oh. Uh-oh. We got a short. Oh, darn it. What the heck? Alright, let's pull this back out. Oh. Can anyone tell what I did wrong? Oh, I'm an idiot. Oh, jeez. Let's try this again. That's an optional connection. Hey, Jack68K. Alright. Let's hide this away again. 3, 2, 1. Chime. Oh, and I forgot to plug in the mouse. Sorry, this is gonna be wonky. I don't really want to move my camera right now. Never do this. Never open up a compact Mac. These analog boards scare the hell out of me. Alright, we're booting, so that means we haven't destroyed the computer. Okay, so not destroying a computer is a really good first step. Okay, so again, this is just the external SCSI. We're not totally to the woods yet, right? This is our not, we're not doing the fancy bit. Okay, let this finish booting up and then I'll shut it off. Okay. Sorry, mouse. Okay. Okay, so now what we're going to do is that's our external BlueSCSI. We're going to take the same drive image out, put that in there, connect that up. Okay, this is the big one. This is our internal test. I'm out of breath here. 3, 2, 1. Okay. We got our red light on our BlueSCSI. Try to make it so that you can see both the screen and the LED on the BlueSCSI. I don't think I'll be successful at that. Alright, we're booting. You can see the green flashing LED on the BlueSCSI. Alright, folks, we got a win. It is so rare for me to get a win. Jeez, oh. Whew. Is anyone else's heart beating as fast as mine? Jeez. Oh, this is fun. This is fun. Why do I do this to myself? Why do you all watch this mess? How's it going, all things DG? Needs more tape. Makes up for all that PC weirdness. Oh, come on. Credit goes to Mr. Vice. Yes. Alright, should we do a little snooper? Let's do a little snooper. This is what your special Mac Plus needs, Dave. Okay, we'll go and do our logic tests. Okay, so we're gonna uncheck all of them. We'll just leave the SCSI and the CPU test. Let that go. Alright, SCSI test passed. Let's make sure the CPU test is going. Alright, so I think we're in good shape. So how's everyone feeling? I know I'm pretty stoked that this actually worked on camera. I know I got it to work once, off camera. And I got my weird wires done before, but to design a little thing and to have it work kind of like this, it's pretty cool. I'm excited, and so it'd be cool to get this thing all buttoned up and total stealth BlueSCSI. Very exciting. So yeah, if anyone wants to do this themselves, go to the link in the description. Um, there's the link to my GitHub page, and basically, you can download the Gerber files and have whoever, um, I used, and I'm not recommending any PCB company in particular, but I used JLC PCB, and they got stuff to me. I think it was like a week. Um, so it's pretty cool. And I got 5 or 6 of them made, and it was $20, I think, after shipping. So it was pretty cool. So feel free to download, have fun. Um, you could use an hour and a half of your life and then lose a couple years of your life with all the stress in doing this. Um, so I don't think we get any more speed here. I mean, the only difference between the internal port and the external port is like a lot of ground. I will go back and do some tests, but between the internal and external. Um, but yeah, for this plus, there's probably not going to be any difference. These are pretty minimal. Oh, let's see if, oh shoot. All my all my BlueSCSI images are on the same SCSI ID. All right, let's do one thing here. All right, so let's see. We just did 2 cycles of all that stuff, and so yeah, there you go. Um, all right, if people want to see, let's just see real quick if the external port works in conjunction with the internal port. I just need to change up my SCSI ID real quick. Um, I think the way the power is routed through this thing, we're actually drawing our SCSI power from the SCSI chip itself. And so the termination power resistor doesn't do anything, or the termination power diode doesn't really do anything for us. So I don't think you'd even need to install the termination power diode on this thing. Sorry. I do have it installed on this board just because that's what I did before. Because I was using this board with an external BlueSCSI. Let's see here. I just need to change my SCSI ID on one of my images real quick. Okay. Oh. Okay. Oh, yeah, I want to shut down. Okay, so this should be SCSI ID 1 now. The internal one is SCSI ID 2. Nice. So when you get to your plus, yeah, KMac, you do need the diode for the external BlueSCSI, but I don't think you would need it for the internal. And technically, if you're using a BlueSCSI, you don't really need the diode for the internal one. It's like a protection mechanism, like from the external devices to come back and protect them from, or protect the machine from getting destroyed. But if you're using the internal BlueSCSI, it's not going to have any of its own power. So, it doesn't matter. Of the multiple files on my GitHub, what is actually sent to the PCB supplier, So all of the Gerber files, so I think they're GRB, and then there's like DRL files for the drill files. Those are what they need. I included the KiCad files as well because I play with KiCad. The PCB manufacturer doesn't want the KiCad files. They only care about the Gerber files. Okay, yeah, and they'll ignore any files they don't know. Okay, cool. So yeah, just give them all of them. Okay, so look at what we have here. Oh, it's going to take you a while to see that on the screen, but we have two BlueSCSI showing up. And so, yeah, we have both the internal and the external connected, and they're both showing up. So yeah, you can still use your external SCSI when you have this mod installed. Whoo! Wow, what a ride. So yeah, blah. So yeah, I have a couple of these left. I owe them to Eric Helgeson for his assistance in doing this and for every other freaking thing he does for the community. So I'm gonna send my 2 spare ones to Eric Helgeson. I might have another batch made up. I also might modify the files a little bit. So yeah, people cannot order the board and parts for me. I am not intending on being a reseller or anything. But I don't know. Maybe if Joe or somebody decides they think it's cool enough and they want to put it on their website, they're more than welcome. But yeah, I'm gonna call that here. That was a lot of fun, and I can't believe it worked. I want to thank you all for being here. This was wild, and I appreciate everyone. I forced Joe to do it. No, I don't think so. Joe's a man of his own will. He's fun. But yeah, thank you everyone for being here today. I'm gonna go through names, and I'm sure I'm gonna miss people, and I apologize if I miss you. But Mac84, Steve, Garth Beagle, Tech Ambrosia, Rudy Zetro, Retro Intel, you're just showing up now. You missed all of the fun. Oh, Rudy, go back and watch the archive of this. Eric's Edge, Dave's Vintage, Apple Tech, Gut Bomb, Eric Helgeson, K-Mag Vintage, who else was here? Oh, I'm going to miss some people. Alan Gracia, Chris Angelis, All Things DG, Vic the Vicar, Jack 68K, Trina's Techno Babble, Action Retro, Tech Night, The Tech Night, Justin D. Morgan, Crazy Furnace Guy. And I'm sure I missed people. I'm so sorry if I missed you, but I appreciate you all hanging out today. Go watch Trina's stream. She's going to be starting at 2:15. Go watch Tech Ambrosia's stream. She's going to be starting at I get my time things done, but I think it's 6 o'clock Eastern. But go check out their pages. So yeah, thank you all for being here. Have a really great day, you all, and I'll talk to you later. And go check out Dave's Vintage Apple Tech stream tomorrow. I'll probably be there working on some compact Macs or some crap. I don't know. Later.